Okay, this is week 2 of Java 1, and we are continuing our work in Chapter 1. And by my recollection, this is about where we left off. And when we were looking at material last time, we were working off of the PowerPoint. At this point, I'm transitioning over to the book, and I will do that often, depending on what the materials are. Now, when we're writing Java programs, there's certain words that we're going to use, keywords, that are reserved for the language. So in other words, if you were to name something, you wouldn't be able to use any of these words in your code to declare a variable or write a method or create a class. Here's a kind of a brief listing of those. And these are some of the key ones. There are more, but these are reserved for the core part of the language. So you can't use these to name things. And some of them that you should be able to look at, like if, that makes sense, right? And if you know for loops and that kind of thing, these words will make sense. And then some of these have very special meanings in certain contexts, and we're going to talk about all those methodically. I don't expect it to stick in your head right away. And it's okay if it doesn't. Just have a mechanism for trying to, find the information when you need it. Because remember, when I test you, you don't have to have it memorized. You can look it up. That's what professional coders do. Now, over time, you will get to know this stuff, believe me. All right. They go into a little talk here about, conventions for how you name things. And frankly, it's pretty subjective. I see people using different approaches and different techniques. The important thing is, at least from my perspective, is that you name things what they are and what they do, because when you come back and look at your code, it makes sense when you look at it. The other thing that you'll learn that I'm going to encourage, especially when your code gets complex, is that you add ample comments to your code. So if you guys remember how to work in VB, where how you'd put in comments, and you probably weren't pushed too hard to do it. And then in HTML and CSS, all those languages have ways to add comments. When you start writing very complicated applications and you're not naming things what they are or what they do, and you omit the comments, you're going to run into a world of trouble. You really are. So there are conventions, and let's take a real quick look, and if you want, you can memorize this. There's Pascal casing and upper camel casing, and take a look at how these things are named. So here they're saying some valid class names in Java, and remember, a class, when we write a program, the whole program file is a class. Okay, so and I have to name a class something. Class names always must begin with a capital letter. Not a number, a capital letter. Lowercase won't work. Uppercase must be there. But that's where that rule ends. When it comes to naming methods, or what we might think of as functions in other languages, or variable names, you don't have to do that. Then you use the other naming conventions. But if you're trying to name things what they are or what they do, so for example, if you look at this inventory item, how they're capitalizing the first letter of the next logical word within the structure. So that's easy to identify. So when you see this sort of approach, it's camel casing because there's a hump in it with the capital letter. And there's kind of a preference for some people to do it one way or the other. I know a lot of people are very keen on using underscores. That's kind of a technique that's kind of gone away, but I do see some people still using it. And notice how they're indicating here what's valid and what's not. For example, this is not conventional for a class name. It's got numbers in it, it's all caps. There are some conventions, though, for example, if you declare a constant, that you do want to use all caps. Not because it's a rule, because it's a convention. And that way, when you look at your code, you can say, aha, that's a constant. Because that's how people do it. Now, this is an important concept, what we call the access specifier. You're going to see all these keywords like this. You're going to see public class. Now, if something is public, that means it's accessible by everything. If it's private, it's not. And there are circumstances in which we need that to be the case, where we want certain portions of code to be able to access something and other portions of code to not be able to access it for very specific reasons. So that is what we call an access specifier. And then notice the breakdown here. We got a class, and then we have the name of the class. And I know I'm going to reinforce these things over and over again. Opening and closing curly brackets to hold everything inside. This layout that you see here is considered the convention, in terms of the name, curly bracket, put stuff inside, curly bracket, and certain types of indenting. You don't need to indent it that way, but it's just considered good practice. All right, Whitespace, see what it says, is optional. If you want, you could make your code one super long string and it would still work. It would be hard to read, but it would still work. So really the format that you put on your code is really for your own benefit. Better IDEs will automatically indent your code. So if you think of like working with Visual Studio when you were doing your VB, you would like type some lines in, then it would automatically put stuff where it goes. The tools that we're going to start with will not do that. I can show you some shortcuts, but they're not going to do that for you. Later on in the course, we're going to switch to some other tools, more powerful ones, that will do that. But one of the reasons I don't jump right to those tools is they put a lot of things in there that are intended to make your life easier, but in the short run will end up confusing you more than helping you. But then once you get the pattern of development, you see how the code should work and what you should be expecting, those tools will actually step in and accelerate your workflow. Okay, so there's different approaches. Did you notice this first snippet of code that we looked at, how the curly bracket was here? So instead of being placed after that line, it was placed below it. And then there's people that like to code like this. That's fine too. It'll still work. All right. And all these different indenting styles have names to them. You don't need to worry about memorizing those.
Just be consistent with it, right?
Just be consistent. Do something that works for you is really what it comes down to. Well-formatted code is a lot easier to contend with, especially when you have problems. Because if you're consistent in your layout, it's really easy to spot if you're missing a curly bracket. So for example, if you use this form of layout, it's easy to see that you're missing it. Whereas if it's up here, it might blend in a little bit more. But I'm going to tell you, because this is what's happened in my life, is that the more I work with code, I've got like a built-in debugger. I can just like see the mistakes in the code a lot faster than most people because I just look at it so much. So, and you'll get that way too when you work with any particular language for a long time. Excuse me. All right, so they go through here and they kind of break down all the different components, and you'll get to learn what all of these mean. I don't want to like belittle this right now. We are going to cover all these little details as we go, and I don't want to inundate you with facts before we start to code. But as we step through, you'll be like, what does static mean? Well, you'll find out. Generally speaking, in this context, it means we're not sending back any information. It's not going to change. All right. So they go through on this page, on page 20, and they very explicitly explain what each one of those components do. What I recommend is you don't listen to me talk about it, that you read it in detail, and you'll pick it up as you go. There are certain words that we're going to use over and over again. And remember I told you last week, like this statement right here, public static void main string square brackets args, you're going to memorize that. Because if you want a program to execute, you have to have that in there. All right. Once you've created code, you will save it as a text file, not with a TXT extension, it'll have a Java extension. And then once you have that code written as a file, you then hand it off to the compiler, which is just a piece of software that runs through the code and it looks to see if it's okay. First it looks for mistakes. If it finds any, it tells you where they are. And then if there's no mistakes, it compiles it into executable code that the computer can run. So that's part of what we're going to learn here. Now, I know that a lot of people, when they read these books, they tend to like go through it really fast, right? I don't get too many students that read the chapters in complete detail, and then the ones that do, I can totally tell because they ask all the right questions and they know all the right information. So notice this line here, it says Appendix A contains additional information on saving a Java application. I'm going to tell you right now, Appendix A is very important if you've never done this before. You need to go to that appendix, like I'm going to do right now, so you can see how everything works before we actually try to run code. So with
you can show something on that in the path variable so you can actually compile and run.
Yes, absolutely. And I'm going to show you a technique, because a lot of people aren't even familiar with what path statements are. We don't work on a command line operating system anymore, but back in the old days, back in my day, when I first started working IT, our standard configuration was like DOS 3.0, WordPerfect 5.1, Lotus 1.2.3. That was like there was no network, that kind of thing. I don't know if there were even hard drives, honestly. But everything was done on the command line, and knowing how to do certain types of commands were very important. And being in an IT program, even though you might not be operating a computer on a command line, it's still pretty important to understand how those things work. And we're going to do a little bit of command line stuff here to start with. And then you can forget it, because we're going to switch to an IDE. But it's important to know that if you don't have an IDE at your disposal, but you still have the Java JDK, you can do all your work from a command line. That's how we used to work. All right, so let's jump to Appendix A real quick. Page 919 according to this. And these are the topics that go with it. So we're going to look at the Java Development Kit, what we call the JDK, and we're going to learn how to compile and execute a program. Now what's really odd is they're not showing this to you right inside the chapter necessarily, and this key information is at the back of the book. Because they make these assumptions. Some people, when they're teaching, they have their students go right to the IDE, and probably when you're going to end up teaching, that's probably what you want to do. We're in an IT program though, and you guys need to be a little bit of a notch above like all your regular people out there. You need to know some of these system level things, you really do. Not expecting you to be an expert on it, but you must learn. Excuse me. All right. Java has many different flavors. They're currently on version 8. Our previous textbook worked on version 7. There's some significant changes in the last couple iterations of Java. Java 8 has some really cool new things built into it. You won't learn all of those until you get to the Java 2 class. But one of them is lambda expressions, where you can write event handlers using one character. It's beautiful, instead of like a string of like 50 characters. But Java requires a few components to allow us to be able to author and execute the software. Now, many of us on our own machines probably already have Java installed because you've downloaded a piece of software that required it, or maybe it came pre-configured on your machine. That's often the case. So one thing you can do to find out if you even have Java on your machine, just hit your start button and start typing Java. And you notice that this is Windows 10 now. Windows 7, XP, Vista, 8, they all have this capability too. And it just searches through my system and finds Java. Now, just because it's there doesn't mean that we have the tools to actually create Java programs. So let's kind of do this in a couple steps here. I'm going to go to the control panel, and if you're in your start menu, I don't know what version of Windows you guys are running, Windows 8.1 or Windows 10, if you right click on the start icon, you will see that you have a control panel. Mac users, we have at least one in the room here, you need to go to System Preferences, and then if Java is installed, you will have an icon in the panel. And if I was able to remote connect to my Mac right now, I would show you that. But if you go into the control panel and then come right up here to the search window and just type Java, it'll find it. You can click on it. I think I clicked on it. There we go. And then it'll bring up this little control panel. All we're really concerned with is that it's there. If it is not there, you're going to need to download it. And that's where we're going to go next. Now this is going to require two different things. First of all, we need the Java runtime environment, what we call the JRE. And in some circumstances, we also call it the JVM, the Java Virtual Machine. To remind you of what that is a piece of software that runs on top of your operating system that gives Java programs an environment in which to operate. So Java programs do not directly interface with the operating system. They run inside of a piece of software. And that's required to run any Java program. The JDK is what we call the Java Development Kit. And that, if you download it, will include the runtime environment. So as a consumer using Java to run a piece of software, there's a very good chance that you already have the runtime environment, but you very likely do not have the Java Development Kit. Now, Java also comes in a couple of different flavors. We are going to be working in the Java 1 class with what they call Java SE, Standard Edition. It does most of the things that we need to do. They also have an Enterprise Edition. And when we talk about enterprise in IT, we are talking about, not a little mom and pop shop. We're talking about an organization like Gateway, where we're going to run more advanced applications. Okay. Now, I'm going to pop us back over to the core shell, and I'm going to take us to the resources page. And I'm going to be looking at this second entry here. I suppose I can delete this entry now, right? The 7th edition. And I'm going to take you to a couple different websites. And I want to show you what resources are out there, and I also want to kind of guide you because, frankly, Oracle's website is not exactly what I would call user-friendly. It's like people that have done it a lot can navigate through it really quick because they know what to click on. But if you've never done it before, it's really easy to kind of get lost in it. I'm like, I thought I clicked that. Why isn't it downloading? That kind of thing. You don't want to be in that situation. All right, let's take a look at this very first link here. And just keep in mind that Java is owned by Oracle. So they're kind of in control of the whole thing. Oracle is one of those big, giant IT companies in Silicon Valley. They're huge. Very important company. Like Microsoft, like Google, they're in that category. All right, so I'm here on their Java homepage, and you can see right here, software downloads, and you can see top downloads, Java SE. Now we already learned what that is, right? Standard edition. We have the Enterprise Edition, and notice there's a little tool that goes with it called Glassfish. It's a web server component. You won't have to worry about it in this class, but when you take Java 2, we will get into that stuff. Then we have Java FX. That's one of the GUI programming environments. That's a Java 2 thing also. Then there's Java ME, et cetera, et cetera, et cetera, et cetera. So if you actually want to get to the point where you're going to do some downloads, you can click on this little button here, and it'll take you to this page. Now this is kind of interesting, because if you're kind of a novice and you go in here, it's like, well, let's see, what should I download? I'm not really sure. Wow, there's a lot of stuff here. For our intents and purposes, what we need is the JDK. The JDK will provide the development kit and the runtime environment all bundled together. If you're not intending to create code, you would just very simply download this, the JRE, the Java Runtime Environment. That's the component that sits on top of the operating system and lets Java programs run. Okay. If you're developing, you need that component, obviously, because you want your code to run, but then you also need the compilers, the interpreters, the language libraries, and all those things that come with the language. So, yeah, Java Development Kit. Yep, it has all that bundled together. Now notice that there's also a server version. We're not anywhere near that right now. If we had a Java 3 class, that's where we would talk about that. So if you read really carefully, you'll see that that information I just told you actually does reside on this page. And people who work in IT, and they spend many years doing it, you know, did you ever see that Saturday Night Live skit where they have the guy, hey, I need help with my mouse, and the guy's like, move, right? And he sits down and he fixes it. And IT guys have this like reputation for not being very patient because they've spent so much time learning the stuff. And how do they learn the stuff? They sit down and they read, they try, they read, you know. I don't know if you're catching that, but there's a lot of reading going on, a lot of studying going on. And so they're sometimes a little bit reluctant to say, well, just go to that page and figure it out. If you can't figure it out, then you're in the wrong game, right? But that's why you got me. So, but you can see if you're a software developer, you need the JDK. It says right there. Okay, so if you guys that are using your own machines here, go ahead and download the JDK. I already have it loaded up on my machine, so you'll download it and you'll install it.
The JDK, right?
Yes. Yeah, that's really kind of a good point. So you see here at the top, you could actually click the big Java thing, and it would actually be the one you want in this case. But you can see the Java platform. It's got the JDK. It tells you the version number. So it's version 8, release 91 or 92. Excuse me. Notice off to the right of it is a tool called NetBeans. It's a piece of software, full-blown IDE, that you can use to develop Java. At this point in time, I'm going to discourage you from downloading and installing it for right now. And there's a reason for it. It's not because it's not a good piece of software, but there's a better way to download it. This will give you the basic Java tools. But when I have you download it a little bit later on, I want you to download the full, complete, every capability package, which has tools, like if you want to do your HTML and PHP and JavaScript and C++ and yada, 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 it can do all those languages. Plus it has built-in web servers. If you download it here, you will get a stripped-down version that's made just for Java.
Do you get like an account or something like that?
No.
A subscription, or how does the server work?
No, it's free. Open source, free. Take it. Yeah. Well, they're kind of confusing terms there. There's no server component here. You don't need a server to run Java. Although if you are working to deliver content to, let's say, a browser window or push it out to an application, then you do need a server. But we're working on a simple application level right now.
All right.
The server would be your own responsibility, though. It would not be something that Oracle provides. Okay, so you need to go through that process, download and install it. When you're done installing it and it's resident on your machine, you should not be prompted to reboot your system. That's not how Java works. If for some strange reason you have like an old version of Windows that tells you to, then you better, I guess. But in my recollection, that's not a necessity.
Should we download the 91 or 82?
I always get the latest version. Now, some of you might also ask, what if I have version 6 or 7? 6, not good. Very insecure. People have learned how to crack it. 7, better. 8, much better. There was a little time there before Java 7 came out where they were telling people to just completely uninstall Java, step away from it, don't use it. And I just kind of want to dispel that. Most of that was based upon running applications in a browser window. And we've really kind of moved away from that approach quite a bit. Let's jump back over to the appendix. All right. So once you have Java on your system, you are going to need to know where Java is located on your system if you're going to do work from a command line. Now, I know some of you are busily trying to download and install. And when we take a break in a few minutes, we'll make sure that everybody's kind of on the same page before we really start to code. But I do want to introduce those of you that are not familiar with the command line tool in Windows. So I just pressed my start button, and then I'm just going to type the letters C, M, D. And it'll bring up command prompt as an option, or it should. It should. And if you click on it and launch it, now yours might look a little bit different because I have mine, my colors are changed and my font's really big on purpose so you guys can read it. But you will be presented with what we call a prompt. And in the good old days, this is all we had. The famous dir command, right? That's how we look inside of a folder. Dir. That's right. All right. But the command prompt is still one of the most powerful ways to operate a computer because you can do things in the command prompt that you can never do within Windows. You know, things have changed a little bit, but that's still pretty much the case. But the point is that we can develop in this environment, and in some situations we need to drop down to do certain things that we can't do otherwise. People that work on server systems, like for example, like on a web server, we don't run a graphical environment. It's all command line. Why burden the operating system with a graphical environment when you don't need to? It just slows the machine down. I can do everything from the prompt. All right.
You know, and especially if you got spectators.
Right. This looks a lot more like a hacker thing, right? Especially when the font's green.
Oh, you really know what you're doing. No, just copy and close.
You know what's really funny about that green on black? I mean that's kind of like the old colors that you would get on the screen, and I would play with that to get like the best contrast for like doing these videos in the classroom. And that actually is a really good. That green on black I think works really well. It's comfortable in my eyes at least. Maybe it's a little nostalgic or something.
Another nice shortcut to use to get to the command prompt is you use Windows key and R, and then just type the number in the run dialog box, and then just type in CMD. If you're not in the
Yeah, and that's essentially what I did. So Windows R, and then type CMD, and that approach is more like the old Windows XP, Windows 2000 approach, and really since Windows 7 you can kind of do all that from the start menu too. Like with Windows 8 everybody freaked out to this Metro interface, And really, it's just a rework of the start menu. That's all it is. All right, so we have our command prompt, and they're giving us some tips here, basically all the same stuff that we just talked about. Now, they give you a little bit of a breakdown of how to navigate your file system. So if you've never had a primer on working from a command prompt, I'm going to give you a super quick one. All right. So here I'm at my command prompt. You guys saw what it looked like when I first dropped in. And I issued a command dir. And basically that's a directory listing. So the folder that I'm currently in, which is off of the C drive, users directory, and then my user account. And I'll bring it up also in a file folder here so you can see. So C drive, users, and my account. So all the stuff that's listed here is also listed here. So you can start to see the corresponding items. So that's how we would look inside of a folder. Well, what if I want to go to a different folder? Let's say I want to go into my Dropbox folder, or maybe my BlueJ folder. So I'm going to come back to the prompt here, and I'm just going to type cd BlueJ. And now I'm in this folder. And then if I come back and I do a dir, I can see the stuff that's inside there, which is identical. You see that? If I want to navigate around even a little bit more, I can do, let's say I want to go up a folder, I just type cd ... takes me up a level. If I want to go all the way to the root of C, I do cd \. It's really pretty simple stuff. When you've never done command line stuff, it's intimidating, I'll give you that. But it's really not a big deal. It's like once you learn what to do, what commands to type, you're fine. If you don't remember the commands, we got Google these days. It didn't used to be that way. You'd have to buy these big thick books and, there it is. Oh shoot, it doesn't work with this version. With Google, you got everything at your fingertips, so don't ever freak out too.
That's really something to do about command line.
Now, if you go to your C drive, and you can do this in the Windows interface, open up the C drive, and then you'll see you got these two folders for program files. Those of you that work on this level often will know that the one that's got the x86 in the name, that's where we run our 32-bit programs. It's really more legacy type software. And actually there's usually 16-bit stuff in there too. And then the regular one is where the 64-bit programs go. Now here's a catch with Java. Java can have a 32-bit version and a 64-bit version. Which one should you choose?
Depends on your OS, your architecture.
Right. Most modern computers, though, are 64-bit. How do you know? Well, if you come to your file folder, right-click on your C drive, or actually you can right-click on this PC or my computer or computer, depending on the version of Windows that you're running, and do a properties. You should get this screen here, and it will detail your OS, the RAM, your CPU, and all that. System type, 64-bit operating system. Mac people, you're 64, don't worry about it. Have been for a couple decades. So PC people always feel superior because their stuff is cheaper, right? But the Mac stuff is always ahead. Sorry PC people. So we have a 64-bit operating system, so it's really recommended that you run 64-bit Java. Some Java purists will tell you that you should have 64-bit and 32-bit, both for the runtime environment and the JDK. Different schools of thought. My school of thought lately has been just do 64-bit, don't worry about it, because it will still compile with 32 bits just fine. Okay. Now if you want to make sure of what you have, you can go back to your control panel and go to Programs, And you can actually look at what you have installed, and you can see here that in my program list I have Java 8 Update 91 and the Java SE Development Kit. Both are 64-bit. So that's another way that you can verify it. And then if you have any sort of weird problems with it, not likely, but if you do, you can come here to uninstall it. Now, knowing that it's 64-bit, that tells me right away that my Java files are in, off of the C drive, they're in the regular program files directory, not the x86. So we're going to go into that folder, find the Java folder, and then notice that I have a few different things here. I have the JDK, we know what that is. Those are all development tools. And then we have a JRE, and I have version 73 and version 91 of version 8. Now, this is going to be very important when you start to set your path statements, because they're going to give you an example in the book that's going to say, type this in. And then all of a sudden you're going to realize, I've got a different version. So you got to change what you type to match what's in this folder. Okay? So just keep that in your head. I'm going to jump back to the book. We're going to go past all this stuff here. And we're going to look at these two commands.
Wait, is the 8th edition still done with the JDK 7?
No, it's done with the JDK 8.
Oh, okay, it is.
Yeah.
All right. Well, what were you referring to just now?
I'm referring to the particular version, because version 8 has got builds. So this is actually the 91st version of version 8. Okay, so when we look at this little statement here, and what I recommend for those of you that are starting out is to take those two lines and copy them, and then just bring up a text editor. Oh, isn't that nice? Citation follows. Darn ebook. That's why I like PDFs better. All right, and you see it didn't keep the line breaks quite right either. But hey, at least I have an ebook. All right, so I'm taking those two lines and I'm just dropping them into a text file. Now notice this path is not going to match up with what's in my folder. See that? JDK 1.8.0 underscore 66. So I need to match that. I need to put underscore 66 there. Otherwise, it will not work.
I go straight to the file that you're writing?
Well, no. It's not going to be in the code that we're writing. This is a command that we're going to issue on the command line to be able to work from the command line.
Right. Yeah, I had a question about that. I got YouTube, a couple things.
And the truth is, you do not have, remember this, you do not have to work from the command line. It's just good to know. And we'll do like one little example in the U-Do-Its, I think, from the command line, and then we're going to switch over to JGrasp and move on with our lives. But like I said, I always get these purists that always insist on working from the command line. Do all our work from there? Great. If that's what you want to do. All for it. Certainly doesn't hurt any.
I'm a firm believer in do it the most efficient way possible.
Yeah, me too.
Adapt to change.
You got it. I totally agree with that. So please make sure that you do that so that this name here exactly matches that folder name. So JDK 1.8.0 underscore 66 / bin. Do you guys know what bin stands for when you start to see that in folders?
Binary.
Binaries. That's where the compiled programs sit. Okay. All right, so we're... Okay, you're perfect then. It's not really a huge difference between the versions within one version. It's always the little tweaks that they make. So, but we're matching up the JDK, not the JRE. It's the JDK, it's the development kit. Now, if you were so inclined, you could also hard code this into the path statement for your system. If you plan on working from the command line, as a rule, it's because you're a purist and you probably already know how to do that, so I'm not going to give a demonstration on that. They do talk about it here, but you can hard code these things in. But until you do that, you can just very simply take these commands one at a time. I'm going to copy it. I'm going to come over to my command line and I'm just going to paste it in and press enter. Now, it didn't spit anything back at me in a command line environment. That's good. That means nothing bad happened. Okay? So I just told the machine that this is where my Java runtime components are. The commands that I'm going to run to compile are inside this folder. So otherwise, if I didn't know that, I would have to type all of this and then my command. What a pain, right? But now that it's in the path, it knows to look there for the command and run it. That's all that does. All right. Then we would also grab this command and paste that one in. They do need to run separately. And that also kind of does an equivalent thing, but for Java. Remember, with Java, we're working with classes. So the class path, it's all relative to Java. So that's just a simple command that points things in the right direction. All right, so once you've done that, then you are ready to go to actually execute a Java program. So they have a little bit of an example here. So if you were writing a program, you save it with a name and then a Java file extension. When you go to execute it, you simply say Java and the name of the program, no file extension, and it will run. That's all there is to it. So you'll see how that goes. All right, that's basically the important part of the appendix. So let's jump back over to the book. And from what I'm seeing right now, it's really a great time to take a break. So I'm going to actually stop this video here. We'll come back and pick up in the next video. And in class here, we'll do 5 minutes. Sound reasonable? All right, see you in the next video.